Hello बच्चों, let's read the question. Let z belongs to C be such that modulus of z is less than 1 and if omega is equals to 5 plus 3z divided by 5 times 1 minus z, then option 1, 5 times imaginary part of omega is less than 1. Option 2, 4 times imaginary part of omega is greater than 5. Option 3, 5 times real part of omega is greater than 1. Or option 4, 5 times real part of omega is greater than 4. Solution start करने से पहले let's note down the key concept for this problem. So the key concept is, let z1 and z2 be any two complex numbers. Modulus of z1 minus z2 is equal to the distance between the two complex numbers z1 and z2. So with this key concept, let's now start with the solution. In the question we are given, we have a complex number z such that modulus of z is less than 1. And further we also have a complex number omega which is equal to 5 plus 3 times z divided by 5 times 1 minus z. Let's now write z in terms of omega. So therefore we have 5 times omega minus 5 times omega times z is equals to 5 plus 3 times z. So therefore we have 5 times omega minus 1 equals, we have 5 times omega plus 3 times z. Now therefore z is equal to 5 times omega minus 1 divided by 5 times omega plus 3. Now further we are given that the modulus of z is less than 1 and so therefore modulus of 5 times omega minus 1 divided by 5 times omega plus 3 is less than 1. That is modulus of omega minus 1 divided by omega plus 3 divided by 5 is less than 1. So therefore we can write modulus of omega minus 1 less than modulus of omega plus 3 divided by 5. So we can also interpret this modulus as distance between omega and 1 and this equation as distance between omega and minus 3 by 5. Let's now look at the graph. So here we have, so let's say this is the imaginary axis or say y-axis and suppose this is our real axis or say x-axis. Now the complex number minus 3 by 5 will be located somewhere here and let's say 1 is located somewhere around here. Now the complex number between minus 3 by 5 and 1 is 1 by 5. So the location of 1 by 5 is somewhere around here. Now the reason we need this complex number is because here we are talking about the distance between omega and 1 and to the other side of the inequality we have modulus of omega plus 3 by 5 which talks about the distance between omega and minus 3 by 5 and we want that the distance between omega and minus 3 by 5 be more than the distance between omega and 1. So if we draw this line and we write the equation of this line as x equals 1 divided by 5. So for any complex number lying on this line, this complex number say a will be equidistant with the complex numbers minus 3 by 5 and 1. So if I have a complex number to the right of this line, so the distance between 1 and say the complex number b will be less than the distance between the complex numbers b and minus 3 by 5 and with the graph you can clearly see that. So we are interested in the complex numbers, so we are interested in the values of omega to the right of this line. So these are the values. So these are the values of omega, and so therefore this part has a common equation, that being the real part of the complex number is greater than 1 by 5, and so therefore real part of omega should be greater than 1 divided by 5, and this will imply that 5 times real part of omega is greater than 1. So this is our answer. Now among the options, option 3, 5 times real part of omega is greater than 1 is the correct answer. I hope you understood it well. Best of luck and thank you.